Well, hello, ladies and gentlemen, boys and girls. It's lovely to see you all here this evening. I hope you've had a really lovely day. And what a day, isn't it, temperature-wise? But even more than that, what a week for space exploration. This time last week, we were just waiting for the countdown to complete, and now they're on the way back. So really exciting times in space, astronomy, call it whatever you will. It's really good. I'm really pleased to see so many of you here, and to you people on Zoom, it's lovely to see you as well. I think we've got some people here. It's your first time, is it? Just put your hands up if it's your first time. Fantastic. What we do ask people who are the first timers, don't go away without saying hello to us, because we are friendly. We do like to make ourselves known to you and you to us. So please, before you go home, come along and say whether you enjoyed it, which bits you enjoyed, which bits we might be able to do better, whatever, but lovely to see you. So, just one or two housekeeping rules as usual as we start off. The first ones are the fire alarms. If it goes off, please exit safely through the doors each side, assemble on the car park, and we will check everybody is safe. And toilets outside that door, just about opposite where Tony is, the gents, ladies a little bit further along there. And please, for the comfort and enjoyment of everybody in the room, can we ask you turn your mobile phones off and refrain from using devices with any screens which could be a distraction to people behind you. For those of you on Zoom, as I say, it's lovely to see you as well. The main thing to say to you is just make sure you keep your hands away from the space bar unless you want to inadvertently join a conversation here. So the format of the evening, first of all, before we go into that, I want to say a big thank you to everybody who's supported us on the numerous events we've had since the last meeting here. We were at Bengio's school, and then we were at Bayfordbury Observatory. On both of those evenings, we were able to wave to the people in the International Space Station, which we had arranged to fly over on those evenings. That's what we told the children and the visitors anyway. And the number of people who've turned up to the Haggas meetings, that seems to be increasing. Really, really pleased about that. And this week, those people who turned up to Bramfield with the telescopes, it was lovely to see you there as well, and to actually see some of the planets and the stars that we wanted to. Okay, so the format of the evening, after these announcements, that we've got John Fraser is going to give us a talk about the night sky, which is going to be really interesting. And after that, I'll introduce tonight's speaker, Sheridan Williams. So, with no more from myself, I'm going to pass you over to John. Please give him a big warm welcome.
That's not me. Thank you. Hello, right. So I'm going to go through the night sky news for about the next month or so. I'm going to try and make this quick. So I'd like to start with the constellation of the month. This month I have almost randomly picked Leo because it's looking pretty good and pretty high at the moment. Leo in Greek mythology is lion, and it's one of those few constellations that sort of looks like what it's meant to be, assuming you've never actually seen a lion in your life. But it's based on the Nemen, other pronunciations are available. The Nemen lion of Greek mythology, which killing the Nemen lion was Hercules' first of his 12 legendary labours. It had a golden hide that was impervious to any sword or club, and it had claws that could cut through any man's armour. Hercules killed it by grabbing it mid-leap and breaking its back. It does feel it doesn't fit in with the 21st century, that story. In Babylonian mythology, it was also a lion, but I think Regulus, the star just down here, was actually as part of the main. I couldn't find an image of what it looked like. In Sumerian, it was a monster killed by Gilgamesh. So If we look at the constellation a bit closer, the three brightest stars, we've got Regulus, which is a very bright star, is actually 4 stars. It's a quadruple star. It's 2 pairs orbiting, 2 double stars. Down here in Denebola is a star about 75% bigger than the Sun, distance of about 36 light years, and about 26 light years away, Algebra, which is a double red giant star. Now, it's a reasonably bright constellation, but the most distinctive part, which is the crescent, isn't the easiest to spot because those stars are dim. You can see them in a reasonably dark sky, but easy way to find it is to use a pointer. So the Plough, part of Ursa Major, every schoolboy, every Boy Scout is taught, if you start in Mirac and go up to Dubby, carry on up, you get to Polaris and Ursa Minor. But if you carry on the other way, you get to the Sickle. So a very easy way to pick it up. So some of the stuff you can find in Leo is very, very rich in things, deep sky objects to see, particularly galaxies. Now I've picked out a couple almost at random. So we have the Leo triplets. These are 3 galaxies. We've got in the top, we've got M65, down here M66. I have mistakenly not written down the name of this one. It's an NGC number. It doesn't have an interesting name. This gets photographed a lot. It's an absolutely fantastic image to do a bit of deep sky photography with. Another image or group just beyond, the M96 group. This is a group, separate group of galaxies which isn't part of our local group. There's somewhere between 8 and 24 galaxies, and these form part of the Virgo supercluster that we are also in. So the moon, I'm sorry, the moon is just about a third quarter at the moment. It's gonna just about a third quarter at the moment, and it's going to move through the cycles, as you'd imagine. Just before the next meeting, it hits third quarter again. We have got, on the 26th of April, it's going to get very close to Regulus in in Leo, just 1/5 of a degree off. That happens at about 1:30 in the morning, but although it'll be very close anyway. So on the planets, Venus is appearing at sunset, incredibly bright, -4, brightest thing after the moon. It starts off the month more or less in Cetus. It's going to rise earlier every night, and by the 23rd of April, it will be well into Taurus, and it will be less than a degree from Uranus. So it'll be a good time to pick that up. This appears in the sky very low at sunset, and it's going to set about 10:30. It's going to set earlier every night. Magnitude 6, so you'll need a scope to see it, although on the 23rd Venus will mark it for you. If you don't see it this month, you're not going to see it for a few months because it's pretty much going to go out of sight in the next few weeks. Jupiter has been, in my opinion, an absolute star this winter. Every time I've gone out with a telescope, I've seen it, and it has got some lovely views of it. It's been really, really nice. So I spent the last little while moving across Gemini, heading towards the right-hand twin, Castor. It's reverse direction again, gone back to normal motion, and it's heading back across. So it's setting about 3 a.m. It appears in the west at sunset, southwest at sunset, and it's moving back the other way, setting about 3 a.m., -2.5, next brightest thing after Venus. The other planets, Saturn, Mercury, Neptune, and Mars, they're lost in the twilight, I'm afraid. We won't see them for a little while yet. It's a real shame because if you look at where they are all getting very close together, but not really visible from here. So what's happened in the last month? So we're going to start with the elephant in the room, which is Artemis 2. Clearly it launched. It had an incredible series of records. So it's the first time we've gone beyond low Earth orbit since 1972, and it's the first time it's been a crew of 4. The Apollos were, of course, a crew of 3. We've had the first woman, Christine Koch, the first non-American, the Canadian astronaut, Jeremy Hansen, Victor Glover is the first person of colour. I couldn't think of a better phrase, but first person of colour to travel beyond low Earth orbit. It'll be interesting to see with the DEI stuff in the States whether that continues. The commander of the module, Reese Wiseman, is the oldest person ever to travel beyond low Earth orbit. They've reached the furthest distance from Earth. Previously it was Apollo 13, which was also on a free lunar trajectory, free return mission. They beat it by 4,000 miles, so it was a little under 250,000 miles. It's gone to a little over 250,000 miles. So it's an increase of 1.6%, but you know, it's a win. They also had the first toilet beyond low Earth orbit, which broke down. They probably would have had to double the budget if they called a plumber out there. And right, so they've been doing a lot of work. It's not just a joy mission. It's been billed as the equivalent of Apollo 8, which it largely is. The route it's taken wasn't the same as Apollo 8, it's more like Apollo 13. But essentially it's like Apollo 8. So after they separated, they went back to the cryogenic production unit and they practiced some docking. They stressed the life support system by they spun up a flywheel and did some heavy exercise to make sure that the life support system was viable. They tested Orion's performance, the Orion capsule performance in space and in deep space. They did observations around the moon, an awful lot of observations. They actually found 2 craters that had previously not been named. And a very nice touch, the commander, Reese Wiseman, named one of the craters Carol after his wife, who died, I think, in about 2020 of cancer. And the spaceship actually had the name Intrepid, or that module had the name Intrepid, and they named the other crater Intrepid. So it's fantastic that we're back to the moon. So shortly before Artemis 2 launched, actually a few weeks ago now, NASA announced a whole series of new plans. These plans, there were a lot of them, and they were interesting. So previously the ISS was due to be decommissioned about 2030, dropped into the Pacific Ocean. The idea was that they were going to replace it with commercial space stations that NASA would rent time on. So it looks like they've increased the time by 2 years, given it 2 more years of life. They intend to add a module to the ISS, which they will attach commercial modules to. Sorry, they'll add a hub and attach commercial modules to the hub. So that about 2032, they'll separate that off. That will be the new commercial space station. And the old ISS, which is really showing its age, will be dropped in the ocean. So another space station that was under development was the Lunar Gateway. Now this was a space station that was going to go around the moon and be used as a staging post for the Artemis landings. This has been paused. Paused is taken out the back and shot in the head by the sound of it, or if you prefer, sent to a farm where all the space stations live happy lives ever after. Now, they've done a lot of work on that and they're going to reuse it. One of the things they're going to use it on is one of the worst named space probes I've ever heard. It is Space Reactor 1 Freedom, which is just an awful name. But this is a nuclear-powered space probe to Mars, which is going to take the Skyfall unit, which will have 3 Intrepid-type helicopters, more sophisticated than Ingenuity-type helicopters, more sophisticated than Ingenuity, that will be used to explore Mars. So, cool mission, terrible name. They're aiming to have 30 commercial lunar landers by 2027, next year. This is ambitious. I think, and I can be corrected on this, so far there has been 1 successful commercial lunar lander. They want these to explore the moon, help them pick where they're going to land. It's ambitious, but it might work. Equally ambitious, they want to increase the launches to every 10 months. Now, this really is ambitious because currently it's taken them about 2 years to build an SLS. There were 3 types of SLS, 3 blocks. They've actually cut that down to 1, so it'll only be the 1 SLS type launch. Even that is unlikely to give them the 10 months they're aiming for. One of the ideas that might be done is they're going to use other launches other than the SLS to launch the Orions. The New Glenn can definitely launch an Orion to low Earth orbit, but it couldn't get it to the moon. So there are ideas that they could launch that on the New Glenn, use something like a Falcon Heavy to launch a propulsion unit, and then you join those, dock with those, and then send that to the moon. So it sounds to me like quite a sensible idea, but devil's in the detail. So as everyone's probably well aware, Artemis 3 is no longer going to be the first manned or first crewed lunar landing. Instead, it's going to be, in the way that Artemis 2 has been the modern version of Apollo 8, this is going to be the modern version of Apollo 9. They're going to test it docking with lunar landers, and it's whatever lunar lander is available. So that could be Starship, it won't be, but it could be Starship, or it could be Blue Moon, which is which is the Amazon version, shall we say. Artemis 4 is now scheduled to be the landing, and that'll happen in 2028. And then they're moving on. That's the end of phase 1. Phase 2, they're going to start a lunar base in 2029. So start developing that with a view to having the start of a semi-permanent presence on the moon in 2032. And this is all really quite ambitious. But only a few days before Artemis launched, the Trump government issued the latest budget, and there was a $5 billion cut in NASA's funding in it. That may or may not happen. He tried to cut it before, and Congress wouldn't let him. So we don't know what's going to happen there. So, fame. We've achieved fame. If I hit the right button. So there was three bits of fame for the group. I don't know why I put this over on the right. This month's Astronomy Now has got a full-page write-up of the group. That's still in the shops if anyone's interested. It's the one with the moon on the cover. The Federation of Astronomical Societies had a full-page write-up on us as well. And anyone who listens to Three Counties Radio may have found on Monday, our illustrious chairman, Alan, was on there talking about Artemis 2. He's assured me that fame won't go to his head, but he is willing to sign autographs after the meeting. Okay. So, as Alan said, Bayfordbury and Hagobs, and I'm sorry, I forgot the school. We had a few things this month. I do apologise that I only have pictures from the outside at Bayfordbury. So if you're inside, I'm sorry, I know you guys do a lot in there as well. And there's only 5 of us, only one of us, Richard, actually doing any work. Only 5 of us in this picture, and I know a lot of people came afterwards. I do apologise, I just don't have the pictures. But it was very good, it was really busy. Loads of people came in to see it. Last Hagobs meeting happened on Monday. It was probably the busiest I've ever seen. I really do enjoy it. It is great. You get to use other people's, look through other people's telescopes, chat to other people. The hobby can be not very sociable, and I think this is a really nice social way to do it. If you can go with them, if you're a member, it's included in your membership. If you're interested, Rich is at the back, Alana here, they'll add you to the group, and you'll get alerts. You only get a couple of days' notice if you're lucky. Okay, last bit, sort of random compared to the other 3, but I found it interesting. So Vera Rubin discovered that galaxies were embedded in clouds of dark matter. They've found now 3. They found a 3rd galaxy which doesn't have any dark matter, which is very odd. It's been described as the mini bullet cluster. If you know, the bullet cluster is a very famous interaction between 2 galaxies, which is part of the evidence for dark matter, and it's also part of the evidence against modified Newtonian dynamics. Essentially, the stars, when 2 galaxies pass through each other, the stars are like point sources and keep going. They don't interact with much. But the dark matter and the gas, because they're much more diffuse, they will interact, have a net zero momentum, and they get left lagging behind. So the galaxy, the visible galaxy, kept moving. I found it interesting. Okay. So what's happening in the next month? Well, the first thing is Artemis 2 will arrive back, hopefully the day after tomorrow. This will be the fastest re-entry of any, I think it might be any spacecraft, certainly any crewed spacecraft, 25,000 miles per hour. It's about 200 miles an hour faster than Apollo 13 came back. They were originally going to get it to do a sort of skipping stone onto the atmosphere, so go in, come out, and shed speed that way. After Artemis 1, they decided, A, it didn't work very well, and B, it wasn't necessary, so it's going to come in faster. Should come down the Pacific Ocean, somewhere near San Diego, or off the coast of San Diego. It is, if America's got any aircraft carriers that actually work at the moment, they might go and pick it up. Right, so we've got the Lyrid meteor shower. This is happening when the moon isn't too full. All right, I put the 22nd of April. Obviously, it happens a few days before, a few days after. 22nd of April is the expected peak. It's supposed to be 20 to 30 meteors an hour. Probably won't be, but it's supposed to be. And this is the remains of comet Thatcher. So, speaking of comets, we have this rather unexcitedly named comet C25R3 Pan-STARRS. Now, I've only picked one day and I didn't write down which day. It's moving a heck of a clip to us, moving in that direction. So if you're going to go and look at it, do look up where it is tonight. It's about Mag 10 at the moment, so you're not going to see it easily. It hasn't quite gone past the sun yet. 26th, it will get to about half an astronomical unit of the Earth. It may get brighter. The golden rule with a comet is that they're like cats, they have tails and they do whatever they want. It could get bright, it might not. If you don't see it this month, you will never see it because this thing's leaving the solar system. It's not coming back again. Another meteor shower on the 6th of May, a bit later. Moon will be a crescent. This is a meteor shower that's the result of Halley's Comet. Again, you can get it a few days before, a few days after. Okay, so what I always enjoy most is the Astrophotography Club. This month I'm going to disappoint you all because I'm going to start with these pictures. Fiona and myself went up to Trondheim to see the Northern Lights. They were magnificent, absolutely magnificent. Although looking at that now, I think I need to lower the saturation of that one at the very least. I've got to say, I haven't properly developed all of these. I've been sort of half-heartedly doing it, but it was absolutely fantastic. Not up to the usual standard, but I don't often get a chance to show off my holiday pictures. Okay, so this one's from Alana. Alana, she was in a previous one a couple of months ago. She's fairly new to astrophotography. She had been using a C-STAR, a smart telescope. This one, she's graduated to more traditional types of photography, and she did this. This, I think, was about 5 hours of work. This was only the second image she's ever taken through on a traditional telescope. Absolutely fantastic image. The upper one is the Cigar Galaxy, and that one is M81. This is located just off Ursa Major. And Alana did give some credit to Steve for helping her develop this, to process this, but she took the image. Steve, who isn't here tonight, has done some brilliant images of Jupiter. They really are good. I do not think that screen is doing them justice. He did several, and he actually put an animation. I couldn't work out how to get the animation down to show it, which was very good. I think that's Callisto, but I am guessing just based on it's off the equator. I'm probably wrong. I've got a 25% chance of being right, but don't blame anyone else. Okay, from Martin we have the Jellyfish Nebula. This is a supernova that exploded about 30 to 35,000 years ago. It's about 5,000 light years away. Anyone around at the time, and there were people around, probably could see this, and it might have, even at that distance, may have been bright enough to see during the day, but certainly would have been brighter than night. Absolutely brilliant picture. I do love the processing of that. This is in the Twins. This is just near the Twin Castor down here at the foot. as I said, the Leo triplets are a very popular astrophotography, M65, M66, the one I can never remember. If you weren't listening, it's there in Leo. That's from Steve, a really good one. I think he took that on March. He only took it last month. In March, several hours of work. Final one. This is from Martin again. The Horsehead Nebula is one of my favourite sights in the night sky, one of my favourite images. It's absolutely great, and this is a really, really good as I have ever seen image of it. It's situated in Orion, so it's just off the belt in Orion. It's one, as I said, it's one of my favourites. I've never managed to actually see this with my eyes. It's a very small thing, so credit to this photo to say the least. I tried it on Monday, could not see it, but I wasn't having a lot of luck on Monday. Anyway, that's it. Any questions? You hopefully see. Sorry? On the moon? No, I said Mars. If I said moon, I'm sorry, I meant Mars, yeah. No, they're using the Lunar Gateway to build a probe to Mars that will carry 3, yeah. Although they have got hoppers. One of the one of the missions, the commercial missions, they wanted to do, they called it drones, which seemed odd, but when you looked into it, it was hoppers. They would be able to basically just go up on jets for a bit. Okay.
Well, thank you very much indeed.
I don't need that.
Okay, thank you very much indeed, John. They're absolutely fabulous pictures and a lot of work that goes into that presentation. That moves us on to the next part of the evening with our guest speaker, Sheridan, who's come along. I was reading through his CV. He's had a very exciting life, not just in astronomy, but very much into computing. And I was reading through that he was working at the Bletchley Park as a volunteer, and he was working on a computer called the Bomb. I'd never come across that one, but I had a little look at it and found that it was a very significant contribution to saving lives. So that was brilliant. And of course, a little bit of a racer as well. And I heard that he's had a bit of fun with his Ferrari as well. So I think a man of many talents there. Well, he's going to come along and tell us about some interesting facts about astronomy. At the end of it, there will be a chance to ask questions. So if you have a question, please pop your hand up. We'll bring the microphone to you. And those of you who are on Zoom, if you've got a question, use the chat facility, send it down, and we'll get the questions read out. We'll aim to finish at about 9:30, so please give a big warm welcome to Sheridan Williams.
So what I'm going to do is start off with a talk about interesting facts to do with astronomy, but later on, because there's an eclipse coming up, really give you more information about that eclipse and where to go to see it and how to see it and so on, because there are 3 eclipses that will go through Spain in the next 2 years. 3 central eclipses. So normally I give a talk on eclipses, so I've patched that back a bit into it at the end. I'm sorry, I need to move over here. Okay. So let's move on. So I think the first thing to do is to talk about the calendar, because the calendar is arranged as, I'm sure a lot of you know this, but I'm refreshing your memory, of course, that the Gregorian calendar was changed in 1582 in Europe, but not until 1752 in Britain. And because the early calendar worked on the basis of 365.25 days, it got out of sync fairly quickly. And so therefore, by about 1700, the seasons were out by about 11 or 12 days, which was actually quite awkward for people looking for farmers and so on. So by adjusting it so that it was more accurate, they needed to change it so that there were leap years not only divisible by 4, but if they were divisible by 100, there wouldn't be leap years. Okay, but that wasn't quite right. So they had to say, well, every 400 years we will make it a leap year or not. So it's quite complicated, but that was the way. So Wednesday, the 2nd of September, if you were living then, was followed by Thursday, the 14th of September. And there's the calendar for that particular month. And I'm sure that there's some actually real calendars around. That's a simulated one there. And it must have been quite unusual. And the ramifications of that were that, that the legal new year had to move from the 25th of March to the 1st of January. 11 days were removed, and people were worried that their rents, wages, and all sorts of things were not going to be adjusted, and they would lose money out of it. So this has ramifications today because it means that the financial year now ends on the 5th of April. And the reason for that was that, that the quarter days were the days in which you paid your rent and all sorts of things. And the 4 quarter days were on the 25th of March, 24th of June, 29th of September, and 25th of December. And that means that, of course, 25th of March, if you add these 11 days are missing on it, it gives you the 5th of April. And a lot of people say, what a funny date to have an end of year, but that was really based around that. When we're looking at Easter and the equinoxes, Easter dates repeat every 5,700,000 years. Now, we're not particularly interested in that. And 19th of April is the most common day for that. And as Easter's just about to come up, it seemed topical to discuss that a little bit more. So it occurs on the first Sunday after the full moon, but occurs on or after the spring equinox. If the equinox is on a Sunday, Easter is moved to the following Sunday. Right. So it's simple and quite logical, but unfortunately the rule doesn't quite equate to Easter when it actually occurs, because the Christian Church, who determine when Easter is going to be, always assume that the equinox is on the 20th of March, but it can occur on the 19th, 20th or 21st. So things will go a bit funny when you get to 2038, because the ecclesiastical Easter will actually be the wrong date compared to the date it should be. But I'm sure the church will win and it will be on the date that they want it to be anyway. So 2008 Easter Sunday fell on the 23rd of March, which was the earliest possible bar one date. And that hasn't happened since 1913 and won't happen again until 2160. But only 3 years later than that, the 2011 Easter fell on the second latest date, or 24th of April. So only 3 years apart, it went from the very earliest to all virtually the very latest. And that hasn't happened since 1859. But I don't think many people were going, oh my goodness, this is surprising, Easter hasn't happened that long. But this is the shortest gap of 3 years possible between the extreme dates in the 5,700,000 year cycle. So we are living in exciting times. The earliest possible date for Easter is the 22nd of March, when it hasn't happened since 1818 and won't happen again until 2285. And the latest Easter is 25th of April, and that occurred in 1943, so fairly, and will occur in 2038. So that's a very interesting set of facts there. March Easters are always isolated. You can't have 2 Easters both occurring in March. Isolated April Easters are rare. This was last in 1990s. They tend to alternate between March and April as the time goes on. 10 successive April Easters can occur very rarely. Well, the next one won't be till the year 2856, so don't bother to mark that in your diaries. Now, this goes back to this business of the church thinking that the equinox is always on the 20th of March. The spring equinox is the 21st of March, people think, or 20th, 21st, the summer solstice, 21st of June. People seem to have this thing, and I think the papers can often get it wrong, and the people can sort of descend on Stonehenge perhaps at the wrong sort of time. But the spring, the vernal equinox, usually occurs more often than not on the 20th of March. Now, it can fall as early as the 19th, but that hasn't happened until 1796, and it won't happen again until 2044. So the autumnal equinox occurs on the 22nd or 23rd of September, but it will occur on the 21st in 2092. So this is all to do with orbital mechanics and so on. So it'll occur on the 24th of September, again quite late in 1931 and 2303. Let's quickly go through that one. So the effects of you're aware, obviously, that the Sun can orbit the Earth. So the Earth orbits the Sun. Earth orbits the Sun in an elliptical orbit. So sometimes it's closer and sometimes it's further away. And people tend to think that when we have our summer, which is in July, it's we're closest to the Sun, but we're actually furthest to the Sun. And in fact, what that leads to, in fact, our summers are longer than they get in the Southern Hemisphere. So that's a little bit of a bonus for not being quite as close to the Sun. You were looking early on about planets in the sky, and it is interesting. I used to do the BAA handbook for a few years as a director of the computing section there. And it was interesting because really you could start regurgitating handbooks from the past, because certainly Mars virtually repeats its position in the sky every 32 years, and Jupiter every 12 years, and Saturn every 30 years. And the moon's phase recurs on the same date every 19 years. So you could sort of go back and save yourself a lot of work by looking at these repeated cycles. So not going into the maths here, but the point is that there are resonances between things in orbit. And an example here is the orbital period of the 4 Galilean moons. So as you can see, Ganymede goes around as a ratio of 4 to 1, Europa 2 to 1, Io 1 to 1. And so in this particular case, you can see they will all go back or around. So it is possible, of course, to have Jupiter with no moons visible, because they could all possibly align at the back of it. That's a fairly rare occurrence. Transits. Now, we had a transit fairly recently of Mercury. You're not going to get another transit of Venus for a long time, but a famous mathematician called Jean Mears, who is 97 last week, he's Belgian. He likes calculating things and when they will happen. And one of the things they have said to him was, is it possible ever to get a transit of Mercury or Venus at the same time as a total eclipse? And he started to do some calculations. Now, if you think about it and you know a little bit about orbital mechanics, then for everything to align, the moon has to be in the right place on its orbit to cross the ecliptic path where the sun traverses. Similarly, Mercury and Venus, they're slightly tilted in orbit around the Sun to the Earth's orbit. And so they've got to be in exactly the right place for it to happen. And unfortunately, or just more likely, very unlikely for Mercury and Venus to be exactly in the same place, exactly the same time. But planets do precess, they change their positions, and things do move. You can get... this is all getting a bit complicated. Blah, 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 blah. All right. Right, so here we are. He calculated that there will be simultaneous transits and near simultaneous transits of Mercury and Venus. The first one will be in the year 13,425 on September the 17th. And then 69,163 and 2024, 508. Well, most people go, well, that's ridiculous. But my point of view as a mathematician is that this shows you the precision of the heavens and the accuracy with which you know things. What you don't know is what time of day it would happen. You know it'll happen, but the Earth is slowing down in its spin, so you're not sure which side of the Earth will see it. So there's a problem with that. I was giving a talk I used to host people on total solar eclipses, and I was giving a talk one year in Tahiti, to name drop a bit of travel, and I was talking about an anomaly that Jean Mears also detected. He said more total solar eclipses happen on a Wednesday than any other day. Now, if you remember the 1999 one was on a Wednesday, I think the next eclipse on a Wednesday. It does happen to see that, but as a mathematician, that is complete and utter, just total coincidence. There's no absolute logical reason at all for it. And one of the guys on the eclipse came up to me after I'd given my talk, and he said, "The one on September 17th, will it be a Wednesday?" as if it was absolutely critical for him to know. Well, there's an example. That's the one that will happen on the 26th of July, 69,163. And here's the one where Mercury transits, if you're in the southern hemisphere, and you can see the moon starting to become in eclipse the sun, and there's Mercury there. And there's one there during a Venus transit in 15,000. And it's possible that there are simultaneous transits as well. But if you go to another planet, Mars will have to wait until the year 571,741 to see simultaneous transits of Venus and the Earth, of course, because the Earth will be there. And of course, if you can see a transit of the Earth, the Moon will be there as well, so you'll see a transit of... So let's have a little look at, we were looking at the square of Pegasus earlier. The square of Pegasus is a constellation that really provides a good test of seeing how good you are at seeing things. Not sure if you've ever tried it, do a star count. You can also do it in Orion as well at different times of the year. So there are two stars within of magnitude 4.6, so that should be relatively easy to see. There are 8 stars of magnitude 5.5, and if you're in a dark site, well, your limiting magnitude is about magnitude 6. There are 13 stars of magnitude 6, so really it's a good test of your vision. But there are 31 to 37 of magnitude 6.5. Now, I know someone whose wife can actually see the satellites of Jupiter with her naked eye. And he has proved that it's true because he's taken her out at night and said, "Right, how many satellites are there? How many moons are there?" And she goes, "Oh, I think there's 3 tonight." And he goes, "Well, what side are there?" And she goes, "Oh, 2 on the right, 1 on the left." And he's tested her several times, and she can do that. And there are stories of people being able to tell from the Incas and so on who could tell the phases of Venus. So there are people with incredible eyesight, and there have been some famous astronomers who can really see an awful lot. So there are Julius Schmidt in Athens in the mid-19th century counted 102. So that shows how dark it obviously was then. But of course, that's he obviously had exceptional eyesight. So here's a little example. There's the square of Pegasus, and there are the 2 brightest ones. Once you get down to magnitude 5.5, there are scattered around a few more. One up here. When you get down to magnitude 6, there's a few more appear. And the top left star in Pegasus isn't in Pegasus at all, it's in Andromeda. I just think that's bonkers, isn't it? That's not in Pegasus. It's called a square of Pegasus, but it's actually in Andromeda. If you did the star count with Orion, there's Orion, there's the belt. You remember seeing the Horsehead Nebula about there. By the way, you can often see the fuzzy Orion Nebula with the naked eye in a reasonably good sight. So there is what most people see from that. If you go down to magnitude 4, there are a couple more there, and 1 down there. 5, you get a couple more in, and magnitude 6, you get a little group of them that appear there. This screen is not as clear as that. Another interesting fact is that the pole star the Vega's distance from us will have shrunk from 24 to 17 light years, and it have a magnitude of minus 0.8. And all the other stars will have receded, so got fainter. So at one point, Vega will be the brightest star in the sky. So let's have a little bit about eclipses, because this is where we can actually talk about, watch a couple of videos and so on. So I'll pop this in particularly because of the 3 eclipses coming along. So just to remind you, because of course you all know that you will only ever see an eclipse every 375 years if you stay exactly where you are. But of course, you may see 2 in 2 years if you're in the right place. You may not see 1 for 1,000 years in the wrong place. John Mears, this mathematician I was talking about, worked out that there hadn't been a total eclipse that went through his house for over 1,000 years. But a friend of mine went to Angola in 2001 and 2002 and saw two in the same place a year apart. So the frequency is a bit scattered around. So the frequency of an eclipse depends on your latitude. So your latitude, we're fortunate up at latitude 50-ish, and that probability comes down to 1 in 315 years. And if you're in the southern hemisphere, it is less. So there are good reasons for that, not just statistical reasons. The reasons are that the moon, the equatorial regions favour solar eclipses. The northern summer of the Earth is at aphelion, and therefore the sun's disk is smaller, favouring eclipses, and so on. All these statistics, let's not worry about that. So here we are with a nice table of all the eclipses that go through Britain. I went to see my first total eclipse in the 1980s, and I said to my wife, I'm going to see an eclipse, and she said, oh, well, what's all that about? And I said, oh, well, the moon goes in front of the sun, and it goes all dark. And it lasts for 2 minutes or thereabouts. And she said, well, I'm not coming. I've got to waste my time to go somewhere to go dark for 2 minutes. So I said, well, it actually goes through Bali. Oh, I'm coming, she said. So I've now seen 19 total eclipses, and she's been to every one apart from the one in Siberia because she doesn't like the cold. So I was then persuaded to write a book listing all the eclipses that go through Britain from the year 1 to the year 3000, so that you're well covered for your future generations. But this is a statistical table, and I've popped in Hatfield up here. You're not very well off in Hatfield. Remember that Britain isn't a particularly big country, right? So isn't it interesting how the statistics, even in such a small country, vary so much? So for instance, in the Isles of Scilly, they've seen 18 solar eclipses in 3,000 years. So their frequency is 1 every 167 years. Dover, poor old Dover, has only got 5, so it's actually 600 years. So for here, this location here, the year 129, the year 228, 319, 458, 878, 1715, very famous one, Edmund Halley predicted that one, 2151, 2600 and 2726. Just a little bit about eclipses in terms of statistics. The maximum number of solar eclipses any year is 5 and the minimum is 2. The maximum of lunar eclipses any year is 4 and the minimum is 2. However, there can never be more than 7 eclipses any year, but there must be at least 4. So this is strange, isn't it? Because it sounds as if there are lots of solar eclipses happen. But of course the problem is that a solar eclipse is only visible if the sun is above the horizon. Whereas a lunar eclipse, anyone on the whole side of the Earth where the moon is there can see a lunar eclipse. So people think lunar eclipses are far more frequent than but total eclipses are a different matter. So the longest possible total solar eclipse will happen in the year 2186. Well, it's the nearest example. The longest possible theoretical is 7 minutes 32 seconds. Now, I think it's remarkable that only 3 seconds shorter than the theoretical maximum happens again in a near lifetime. And of course, it has to happen along the equator because the moon shadow is travelling at thousands of miles an hour across the surface, but the Earth is also turning at 1,000 miles an hour. So if it's on the equator, it makes the eclipse last longer. So remember, the equator goes to the Amazon and this part of Africa. So at this particular point, it will be that length. The majority is in C. You'll still get a good 7 minutes here. So the longest possible eclipses are from in the year where we are in the years 2000, 7 minutes 32 seconds. In the past, they haven't ever been quite as long, and in the future, they won't be quite as long. So we're actually living in a time where total eclipses are perhaps at their peak in length. An annular solar eclipse is where the sun isn't covered up by the moon, so you see a bit around the outside, and the longest eclipse of that is 12 minutes 9 seconds. Now, they're only of interest if you are a bit of a fanatic, or you can see them low on the horizon. And this was taken from the Isle of Lewis and the 2003 eclipse. Right, before I show a video, I just want to talk about one thing about eclipses. Do you notice anything really weird about this? There was one in -761 of 7 minutes, and virtually the same length. It happened only a little bit later. And then another pair of years, forget that one, but then in 2168 and 2186 you will get 2 very long eclipses. If you do the calculations, they're 18 years and 11 or 10 days apart. And this is called the Ceros. This is a well-known thing that's been known for a long, long time, and people could predict eclipses by understanding that eclipses happen and repeat after 18 years and 11 days. So the longest possible total solar eclipse in Britain is 5 minutes 39 seconds, and here is the track for the year 2726. Notice it doesn't go through Dover. If you were in Cornwall in 1999 on the 11th of August, you would have seen total solar eclipse from here, and the eclipse shadow was only about as wide as 3 or 4 of my pointers things there, so that sort of width. So look at the width of the shadow. That's because the moon is incredibly close to us and covering as much of the sun up as possible. All right, let me just see what the next slide is. Right, yeah, let's just do this one. So you're projecting a circle onto a sphere. If you project a circle onto a sphere, then you can get an ellipse. So the maximum width for the shadow is technically 269 kilometers across the minor axis. For an annular eclipse, 370. So this 269 kilometer track isn't very wide. This is why you have to be in the right place to see a total eclipse. And the width of the shadow, as I say, is that. So here's the shadow of the 2600 eclipse. So that's the shape of the shadow, an incredibly elongated shadow. And it goes through the whole of Britain, but not Dover, of course. So what are the chances on the 5th of May 2600 it will be cloudy everywhere? You could have a statistical gamble on it. Because, you know, a lot of Cornwalls were cloudy for the 1999 eclipse. All right, let's just see where we are. 2 more and I'll show a video. Right, so someone, Jean Mears, actually calculated also that you can have eclipses that go through the same point in close succession. And his record for finding that was in a place, remember this is Egypt here, a place in Egypt in the desert where 1, 2, 3, 4, 5 eclipses all go through that little spot of land shaded black there. So if you stayed there for, how was it, 8 years or something, you'd see 5 total eclipses without having to move from anywhere. But this is the interesting one. This is Britain. Not too distant future. Okay, they don't all go to the same place, but if you travelled in a small island of Britain, you could see 7 total eclipses in 67 years. With the 2151 would obviously go through where we are, or will it, so I shall talk about that in a minute. Right, so I want to show you a video of someone who is a fanatical eclipse chaser, and he made this award-winning video. And his name is David Makepeace, and he's a Canadian, and he's very eccentric. So one of the things that you probably weren't aware of is that a minute before totality on the last eclipse, 2006 one, he said 1 minute to go, and it was effectively broad daylight. Now that's what it would have been like in London on the 1999 eclipse. In other words, people thought this was an incredibly exciting eclipse in London, and yet they saw nothing. You know, it got a bit cold, you know, a bit whatever. It's this business of the difference between 99.99% total and not total. You know, 99.9% eclipse is not a total eclipse. But still, the sun is so bright, shining straight through. It's no darker than on a cloudy, a thunderstormy type day. So I need to try and talk to you a little bit about that for the next few eclipses. So before we do that, you need to understand a little bit, or hear a little bit about delta T. On geological timescales, the Earth is gradually getting long. The day is getting longer. The Earth is slowing down in its spin because the Moon is acting as causing tidal friction. So back in 100 million years ago, the dinosaurs would have had days that were only 22 hours long. But although this is incredibly small change and wouldn't be noticeable over a lifetime, of course, it's something that is carrying on all the time. Every day is getting slightly shorter. And these milliseconds all continue to add up. And that means that the timing of eclipses is different in terms of where they actually occur on the Earth's surface. So there's a little example of delta T. So the year minus 5,500, the delta T was 17,000 seconds. And that means that anything that happened, the Earth would have rotated 71 degrees further round than it would have done if you hadn't taken into account. And this is important because for London and Hatfield, here is the eclipse in 2151. So there's the northern limit, there's the southern limit, and there's the centre line. Now if you look, it goes through Luton, London, Hatfield sort of there. Oh, are we going to see it? So here is a calculation. If we expect delta T to carry on exactly as it is at the moment, then we expect delta T to be 106 seconds. And in this particular case, there is the southern limit, and there is Hatfield. So you will see an eclipse of 1 minute 56 seconds. This bit of software here is available free online. It's written by a guy called Xavier Jubier, a French mathematician, and he overlays it on Google Earth. So you load up his app and zoom in on anywhere on Earth, it's right in full depth because it's a Google map, and click. Anywhere you click, and it gives you the date, the time, the altitude of the sun will be above the horizon, its position relative to north, the speed of the shadow, the length of the eclipse, and obviously the latitude and longitude you're actually at where you've been given that. So notice that it's doing 2,000. Oh, I can't see it. 7,205 miles an hour. So the shadow is crossing you. That's why the eclipse lasts such a short amount of time, because although the moon's shadow is 200 kilometers across, this is just rushing across the Earth. But now let's look at what would have happened if we carried on with the same delta T that we'd had earlier on in this century, because that seems to be slowing down. And here we now have the centre line going through here, and there's the University of Hertfordshire, and you would not have got a total eclipse. You'd have had a duration, a magnitude of 99979.999, but it would not have been total. You would have seen, you would still need your eclipse glasses, and it would still be really, really quite bright. Eerily cold and very unusual, but certainly not a total eclipse. So you've probably heard that before. The last total solar eclipse had happened in 600 million years because the Earth, the Moon is receding from the Earth. This tidal forces is making the Earth's rotation slow down, but making the Moon recede for the conservation of momentum. Let's not worry about that. This is an interesting one. I'll just quickly go on to about this one here. Oppositions of Mars occur on average of every 780 days. And last year was quite a good one. We actually had a good chance of seeing it. And it's true that the Mars came closest to Earth on the 28th of August 2003. Not that long ago. And that was the closest for 73,000 years. So again, we've been in an era where things happen. If you compare it with the opposition of 1995, where it was a pretty long way away, you can see that the diameter has gone from 25 arc seconds to only 13 arc seconds, so half the size of it. And here's a little diagram showing you that in 2003, this is the Earth's orbit, and there's the Mars orbit. That's because of the eccentricity of both orbits. And so you could see as we go around, 2001 was a bit shorter and so on. 1980, very a long way away. So Mars is closest to Earth. You've got to wait till 2729 to get closer than it was in 2003. Right, let's forget about that. A couple more interesting facts that I dug up. Alpha and Beta Centauri, the two bright stars, will be closest in the year 5940 because they are a pair. Castor and Pollux, which you've seen earlier in Gemini, are 4.5 degrees apart. Castor's the northern star. It's fainter than Pollux, although it's designated Alpha Gemini. Now, the idea was that the Alpha star is the brightest star in any constellation. So this poses a question: when it was determined as Alpha, was it actually brighter than the other one? Because stars are variable, but this is not known as a short period variable. So, but that doesn't really answer the question. There are actually 34 constellations out of the 88 where the brightest star does not bear the Greek letter Alpha. And in Aquarius, well, let's have a look at them. So in the southern constellation of Mensa, the Gamma is brighter than Alpha. In Cassiopeia, Beta and Gamma are brighter than Alpha. It's really quite weird. I don't know what the reason for that is. So there are quite a lot of examples in that particular case. Right, in 126 days from today, there is going to be a total solar eclipse in Spain. And here is the track of the eclipse. It starts somewhere near the North Pole, comes down through Greenland, clips the edge of Iceland, and comes round into Spain. This is the track as on Google Earth. So it crosses Spain around Santander on the northern coast and cuts across here. And if you want to go clubbing in Ibiza, you'll be able to see the eclipse. Except there's a problem. This is the end of the eclipse track. This is sunset. So you'll notice that the eclipse is so low on the horizon, and I'll give you some measurements in a minute, because the chances of you seeing it in Ibiza would mean you'd have to be near the coast. You have to be virtually on the seaside on this side, because anywhere inland, the shadow of buildings and any local hills will mask a position. But this is what we're going to see in Hatfield. Now, this is done with Stellarium, and we plug in the date and time in Stellarium, and you can see that the sun is that far above the horizon. There's a tree there, simulated tree. There's an magnified example of it, so you can see, and that's what it looks like true to scale. So there's a huge amount of sun showing, but if you were aware of things in 1999 in London, it really got quite chilly. The atmosphere is really quite weird, and I'll show you a video later of people who are experiencing the coldness and the shiveriness they feel. So here is what most eclipse chasers zoom in on, the weather. What's it going to be like? What are the cloud covers? Well, look, if you go to see it in Iceland, we're up at 80% cloud cover. Doesn't mean there will be 80%, it means there could be none, but it could be total cloud cover. But statistically, Greenland, look, that doesn't look too bad at all. And Astro Trails are leading some eclipse trips to Greenland. I'm not allowed to go to Greenland because my wife doesn't like the cold. So we're going to go down here. Now look at that. Look, we're down at, not on the coast because it's coastal shadow, but inland you've got a really good chance. 10% cloud cover if you're unlucky. So this is what eclipse chasers really go in on, home in on. So then you look at the statistics as well. Here is a chart, a photo, a download from a weather satellite last year. And as you can see, this is all perfectly clear. Look at that. Even Ibiza's clear, but just along the north coast, you've got these sporadic clouds because of the sea. And then you look at charts again, looking at the cloud cover. So if you're at the Bay of Biscay and you're, near Santander, then your chances of seeing it are not quite 50%. But if you come straight down to here, and guess where I've chosen to be, a place called Lyon, which is there. There's a big plain there for things. And then it stays pretty good chance of seeing until it gets all the way to the Mediterranean. And there are some actual statistics. So if you pick on Lyon, you'll see that 76% of total sunshine, and you mustn't get worried about the days of rain or whatever it is, because there have been 3 or 4 days of rain in the past, but you have to take your chances. Another thing that people want to know about eclipses is where the diamond ring will be and various other things. So again, if you're into lunar astronomy, you'll know that you can see different craters at different times. The moon librates. It doesn't always show exactly the same face. You can actually see, I think, nearly 60% of the moon. Okay, as it's never facing exactly the same position, and you know where the position will be now, you can see that in this particular case, for this particular date of the eclipse, that this is wildly exaggerated mountains of the moon. And if the moon is tracking across the sun in this way, then these bits of light will be the last bits showing over the moon. And at the end of the eclipse, there will be some shadows there. It's not shadows, so some bright bits there. These would be called Bailey's beads because there's several of them. And if there's just one that's showing, it's known as the diamond ring. So here are the 3 eclipses that we need to focus on. You've got the August the 26th one, see Spain. In August 2027, it goes through Spain, right at the bottom of Spain. And it goes through Gibraltar, and it goes through where my brother lives in a place called Nerja in southern Spain. And I said to him, oh, do you realise an eclipse goes through your house in Spain? Oh, he said, I won't be going there, it's far too hot. Anyway, 2nd of August. And then on 26th of Jan 2028, there's another eclipse that goes this way, but it's an annular eclipse. So it is actually very rare, really, for 3 places. If you lived sort of here, you'd see 3 central eclipses in that short period. But here's the problem with the 2026 eclipse. If you're on the north coast, the sun is 10 degrees above the horizon. Well, 10 degrees is not bad. That's quite a good angle. We have to be right in the middle of some mountains or town not to see that. But when you get to central or to the west, it's dropped to 4 degrees. And when you get to Ibiza, 3 degrees. Now, 3 degrees is really, really low. There is an amazing app, which I'll put a link to there. If there's time, I'll show you later on. And this was developed because the problem is, if you're going to go to Spain, you can't just think, I'll stand here, because there might be a hill in the distance that's covering the sun at that time. And this map shows, for any time of day, for any day of the year, exactly where all the shadows for all the obstacles are. And I mean all the obstacles. If you do it in London, it shows you the shadow of the Shard. It is absolutely incredible. Someone has obviously got some amazing database of every building that there is. I mean, I've only tried it for Britain and Spain, but it just seems amazing that someone has actually collected all that data to do that. It's an amazing bit of software. Now, 2027 goes through Spain, as I mentioned, right to Gibraltar, and then cuts across Africa. I can't imagine many people want to go to Algeria to see it, or perhaps Libya, but certainly Morocco, if you don't want to go to Spain, Tunisia and Egypt are good locations. Again, unless things have calmed down, perhaps you wouldn't want to go to Iran and around there. But the greatest eclipse is in Egypt, in Luxor, and it's 6.5 minutes. But I've seen a total eclipse in Libya, and the total eclipse in Libya, the sun was pretty high, and I think Egypt was even hotter. It's not going to be a pleasant experience, but I mean, obviously the eclipse will be a pleasant experience, but you know, you'll be looking at the sun. It'll be on the zenith. I mean, literally straight up. So you're going to have to, like that guy did in 1998 in the Caribbean with his eclipse glasses lying on. You have to be lying down to see it. But if you're lying down, you can't see all the lovely things on the horizon. We do have 6.5 minutes to see it. So I think a good option would be, I'm thinking of it seriously, Morocco, but it's still going to be 4 minutes long there. So here's a little bit of better map for you to see. So it goes through Morocco, Tunisia, a little bit of Libya, Egypt, and then down through Yemen, but we're not going to go there, are we? If you're worried about the cloud, this is a particularly good eclipse. Look, blue is all pretty clear. Blue, 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 blue. Even blue in up here in that part of there. So that's a good, and here are the statistics of it. Benghazi is Libya, so you've got really good, virtually no chance at all of any cloud at all the way across the north part of Africa through to Luxor. Soon as you get to the coast, the Red Sea, whack, the clouds come in, and once you get up further on than that, the cloud cover is particularly high. And there's an even more detailed map of it coming down through Egypt and through Luxor. 6 minutes 22 seconds. It's the longest eclipse for over 100 years. So again, take your opportunity to see that one. Because I think I'd rather go to somewhere that's not quite as hot, and having been to Egypt before but not having been to Tunisia and other places, I might like to try. So there's the centre line. There's the northern limit. As I say, my brother's house is in Nerha, but it will be a very short eclipse there because it's very close to the edge of totality. Gibraltar would be a very good place to see it if you want to stay on British soil, if that's still going to be British then. Then, of course, you've got some longer duration in Morocco. And if you haven't been to Morocco, it's a great place. 2028, why this appeals to me is that this happens almost exactly on my 80th birthday. So it would be like a birthday treat. And this goes across Australia. Now, we've had 2 total eclipses go across Australia fairly recently, 2012 and 2023. And what's interesting is that if you look at a map, have I got a close-up of the Australian one? Yes, if you look at the map, there's a place called Broome here, just outside totality, and Darwin's about here, but the road is closed between the two, so the only way you can get there is to come down through Alice Springs, go all the way across here, and do a 2,500 mile detour to get to the eclipse track. Exaggerating, of course, because obviously you could get a boat and anyway, it doesn't matter. But this is the cloud cover prospect. So, you know, blue is all nice and clear. Look at that. You know, almost certain to see it all the way across Australia. When you get to here, it's still pretty good. And unfortunately, that's exactly where people will want to see it. That's what it would look like. That's a simulation of what it looked like over Sydney Harbour Bridge. That's the altitude it would be. I mean, what an amazing eclipse. People like taking photographs of total eclipses with rock arches or something in the way, just something to give it a bit of depth or background. 2030, another one goes to Australia there. That's just a reminder of the 2151 eclipse, and that's a chart of eclipses for the next, up to the year 2035. So they sort of randomly scatter around. This is what Xavier's website looks like. You literally click on any eclipse date you want, and when you click on it, it tells you all the details about it and the local circumstances. I'll put that up later on. I'm going to show you a video now of Kate Humble going to see total solar eclipse in 2012. Now, why I'm showing this is because it is true. I hate to admit it, but I've seen 19 total solar eclipses, and apart from the one where I was cloudy, well, I cried for that as well, but I mean, you get a tear in your eye. You get very, very emotional over it. And all eclipses are different, so it's not just a question of, oh, it's just another eclipse. The point about that is that we all know, I take people to the Open University's telescope, looking through a 16-inch telescope, and they want to see a galaxy, and they've seen all the pictures of them, all the fantastic pictures that some people have been taking, and they expect to see that. And I think people don't realise that an eclipse really, really is the most dramatic thing you could ever see. And it is real, it's there. And there's no way you can explain it until you've been to see one. Have you seen one?
Yes.
Good.
1999.
Yes.
We were at Torquay.
Yeah, okay. Oh, well.
Just the right place.
I've got one question. Can I ask one question? Yeah. Okay. So you've been put on this planet to see 2 total eclipses. One of them has to be cloudy. Would you prefer the first one to be cloudy or the second one? One of them has to be cloudy. Now you get different answers from different people, of course. If you've seen a cloudy eclipse, then you don't know what you're missing and you think, I'm not going to bother to go and see another one. Or you're completely intrigued. What's all the fuss about? I've got to see one. Now, I reverse it because my first eclipse was perfectly clear and my second one was cloudy. And I was devastated. I was almost in tears on the floor. I couldn't believe what I was missing. I knew what I was missing. I knew the horror and the money I'd spent to get to see the eclipse and missed it. And I think so you can see it from 2 different ways. But it's an interesting question. You get different answers from different people. Yeah.
Okay, that absolutely fascinating talk there. And the emotions of the people watching those eclipses was very clear, wasn't it?
The Americans are very vocal. They do scream and shout. I mean, if you've been on a plane with them, they often clap when they land, don't they? I mean, that's
I've been on that plane too. Okay, do we have some questions from the audience? We must have, I'm sure. Yes, Jerry.
We have the most unusual coincidence in that the moon and the sun are pretty much the same apparent size in the sky. In all of your calculations and so forth, have you found anywhere else in the solar system where this can happen?
well, if you look at the Jupiter, you can see
Yes.
moon shadows on that, and they're not particularly big. And if you were there, you would see a total eclipse. But of course, the sun would be a lot further away and a lot fainter.
But there's nowhere where you could stand and watch.
Nowhere on that. I mean, on
No.
Mars, the moons are far too small, just a
Yes.
little blob in the middle of the disk, tiny, and annular. So no. And no, it's an amazing coincidence, and it's only perhaps in our time, as I say, in 500 million years' time, you won't get a total eclipse. But what's interesting is the religious significance of this. That if I've been to Muslim countries where they do not allow the population to go and see totality, they have to stay indoors. And watch it on television, or in India where they get very frightened of eclipses and so on. And in the past they would ask pregnant women to rub red dye on their stomachs to protect the unborn baby from the harmful effects of the eclipse. All sort of things that are strange like that. But I went to a Muslim country, Sulawesi in Indonesia, to see the 2016 eclipse. And the local imam, or whatever the person in charge of the religious thing said, was, I want everyone in the village to go and see this eclipse. It's a gift from God. So the same religion interprets it completely different ways. It's amazing, isn't it?
Amazing, isn't it? You had a question?
No, not a question. The thing that I remember of seeing the eclipse was how all the birds became silent just a couple of minutes after the totality.
Yeah. If you're aware of the surroundings, yes. I mean, I was in 1991 in Mexico, and we was on the beach, and a whole flock of pelicans flew down the beach, and I thought, well, maybe they're going somewhere. But in fact, they were aware that it was getting darker, and after the eclipse, they all flew back again. And if you go somewhere, you can hear cockerels crow and chickens, and in the right environments. In Australia, someone said to me, "My goodness, the plants have all closed up. The flowers had sort of closed up on one of them." So there's a lot going on there, and it obviously does confuse nature. It's not too sure what's going on.
Just for a couple of moments, doesn't it? Do we have some other questions? Gosh,
So.
for myself.
We had an excellent solar eclipse event last year in the grounds of Hertford Castle. Now, the one later this year is going to be at the end of the day, which is in a way, it's good because it's a Wednesday, whereas this other one was a Saturday, which was a Saturday morning, absolutely perfect. So, does the society plan to do a public event?
The answer to that is yes, it's on the agenda, but we're still waiting for replies from where we're going to do the location. It's late in the afternoon, early evening, and it's not going to be a total eclipse, but we will see what we will see.
We can see from the diagram how high up it was from my
Yeah.
simulation from Solarium. Yeah.
But again, as it's a partial, is still worth looking at.
Oh, good. No, I'm not.
Do we have any questions
I'm not
on the
saying
internet?
don't go and see a partial eclipse. I'm just saying it's when the media. I mean, my first experience of media exaggerating things, of course, has been experiences where they've talked about. Did you see the meteor shower last night? And the paper shows a picture of star trails. Or tonight's full moon. It's a super moon. Well, it's 1.5% bigger. If you put two together, you wouldn't notice any difference. And of course, they only show pictures of the supermoon low on the horizon with buildings, don't they?
Yes.
And they build everything up to such an extent.
I'd heard that the supermoon experience was like ordering a 16-inch pizza and getting a 16.1.
Yes.
Okay. Well, if there are no more questions, I'm sure that we'll want to say a very big thank you to Sheridan for that fascinating talk, and very much appreciation for coming along. You've brought some books
some
with
books,
you,
yeah.
haven't you?
Yeah.
Now, they are for sale?
Yeah.
Okay,
yeah,
right. No, these books are very special because they will only work if Sheridan activates the text by signing them. So if you want one, come along here. I'm pretty sure...
That's an extra £100.
Extra £100. Okay, right. I'm sure that,
One
you
of them
will
I
enjoy
wrote in
reading
conjunction
them.
with Brat Travel Guide, so it's a bit of a travel guide as well, is for the eclipses starting in 2024, which went through America, 2026 and 27, so it's got both of the eclipses and where to go and what to see and so on in there as well.
Okay, so I'm sure we all want to say thank you very much indeed for Sheridan. Okay, just a few closing announcements. First of all, the next Haggas meeting is on the 22nd of April, coincides with one of the meteor showers, and they've got Logan Carpenter, who's in New Zealand, and he'll be talking about capturing images in the southern hemisphere, in particular the Carina Nebula, and that's going to be in room 1A161. If you haven't been before, it's this building, but upstairs. As you come through the doors, the main doors in the entrance, go up the staircase and just keep going until you see the group there. And on the week after that, I haven't got the detail written down here, only just came through today, but we have got the Institute of Physics have got a talk on astronomy. Forgive me, I forget the subject. Anyone who's got the computer website, you look it up and tell me what it was about. But that's come through. I know it's an astronomy one, so that's the 29th of April in the room just across the way there. On the 13th of May, it's our next meeting here, when we've got the AGM first of all, and then we've got Lewis Dartnell talking about how the Earth shaped human history. Another date for your diaries, a little bit further away, the 11th of July, which is a Saturday. It's Wheathampstead Village Day. We go along to that and we demonstrate telescopes, hopefully some solar ones as well. It's a very enjoyable day and a great way to meet the public. And of course our observation group will be keeping an eye on the weather, obviously as the days, the daylight is getting longer and the darkness a bit shorter. They're going to be a little bit short meetings if we can manage them at all, but they will keep an eye out for you. And If you are a new member, you are entitled to go along to the observation groups and the Haggas groups as well. If you want to go to the observation groups, see Alana or Richard, who's at the back of the room up there. The Hagobs ones, just pop on the website, pop your name onto, yes, you'd like to come along. We're on social media. I have to read this. We're on Facebook, Instagram. You can follow us at something or other. Hartford Astronomy Group, all one word. There's lots of stuff on there. I get lots of reminders about things that are happening. I'm sure you younger folk understand that better than myself. So, I would like to say a very big thank you to both our speakers this evening, to John, that terrific talk updating us on Artemis and the other constellations, and to Sheridan for coming along and telling us about those interesting facts. Can we give those a big round of applause, please? Thank you.
If you want to take a photo of that, that's the various websites that might help you with...
Oh, right. Well, I have one question. Do you mind us if we pop this onto YouTube and so? Okay, so these will appear on the YouTube channel as well. And of course, I want to say thank you very much indeed to all the committee members who've been working tirelessly in the background, and particularly our technical team over here who've kept things running along. So thank you very much indeed to you as well. Give them a clap there. And finally, just to say a very big thank you to yourselves for coming along and making this evening very enjoyable. Hope the sun keeps shining on us, whether there's an eclipse or not. Enjoy the warmth, and we look forward to seeing you in the future. Thank you indeed for coming, and good night. They were a bit cold.